Welcome to another edition of RCE. Again, this is Brock Palen along with Jeff Squyres from Cisco Systems and one of the developers of OpenMP. Jeff, thanks again for your time.
Hey, Brock. We're verging onto my territory again today. We're talking to some MPI guys and some big parallel computing guys here, so this will be an interesting one.
Yeah, so before we get into that, you can find us online at rce-cast.com. You can find all the old shows there, subscribe by iTunes, RSS, etc. So our guests today are two guys who worked on the K computer. You guys may have heard of the K computer. It is currently the fastest machine in the world with an absolutely massive core count. So our two guests are Koh Hotta and Shinji Sumimoto, and I'm going to let them introduce themselves and say exactly what their roles are. So Koh and Shinji, thanks for taking time for the show.
You're welcome, my pleasure.
So why don't you give us a little bit of what your roles are?
So my name is Koh Hotta, and I'm in charge of software development in the K computer and other Fujitsu next gen supercomputing. So especially I have experience in the compiler development. And also the OpenMP, I'm OpenMP director of the OpenMP ARB, and also of course Fujitsu.
Hi, my name is Shinji Sumimoto. I'm a same division with Koh Hotta, and also I'm in charge of development of MPI and high performance communication library. Also, I'm in charge of developing a file system. And I'm also in a board member of MPI Forum, and Jeff and I are very well known, and maybe much time I met.
So I should mention, too, that Shinji and I are on the MPI Forum together, so we see each other every 2 months or so at these forum meetings for quite a long time now, actually. Yeah. So let's go ahead and start with a good general question here. What is the K computer?
K computer, the name K computer is a nickname of the next generation supercomputer built by Riken and Fujitsu. This is a national project of Japanese government science and technology basic plan. So this is K itself is the name of the national project. And Fujitsu is in charge of the development. And K computer uses Spark processors, and more than 80,000 processors are combined in the one system. A very huge size of the computer, and the network itself is TOFU, Fujitsu's or K computer original network. So 3D torus network is used in the K computer. It will be development will be finished in March 2012. But so now we have maybe 80% of the system is already developed.
So when you say it's 80% developed, the hardware is all in place. You're talking about the special software stack to support such a large system?
Yes, special software stack means that operating system is Linux. Linux is used in the K computer, and compiler it has Fortran, C, C++, and so the MPI using on that system is matched to the this TOFU interconnect system. And it is based on OpenMPI. So we use OpenMPI and to match to the K computer. And we had a lot of issues. For example, so huge systems, so we need to reduce the overhead of the operating system, and some use supporting facility to use schedule the job scheduler or etc. So they are Kind of original, but so enhanced or the tuned facility for our Fujitsu's current or former previous system of the supercomputer. And it has 8-core Spark processor is new for this K computer, and it has 8 cores. And our compiler has automatic parallelization facility on 8-core processor. So thread parallelization is done by automatic parallelization, and also, of course, OpenMP. And hybrid programming, so thread and MPI hybrid programming is achieved by this, used by this system. And so to easy programming, so we enhanced our automatic parallelization, because programmer doesn't want to think about 2 levels of parallelization, thread parallel and process parallel. So because of the automatic parallelization, programmer don't need to think about thread parallelization. And this is became available not only by compiler optimization, but also by the hardware facilities. It has shared cache and hardware barrier, high-speed barrier, make it available. This is an abstract of the K computer.
So who are the target users for the K computer? What kind of applications will be running on this machine?
K computer is developed for kind of general purpose. So there are almost our target users are 4 kinds of target users. And one is life science, and the next one, energy research, disaster prevention, manufacturing, supporting manufacturing, and astronomy and astrophysics. These 5 kinds of the area is the target of the K computer right now, but it is very, very general purpose. And so maybe most of the users are researching areas, so academic and research laboratory. But so we are also expecting that manufacturer or the industry people will use the K computer also.
So the K computer is, very, very large by core count, and it has a very specialized network to enable MPI scaling. What do you expect this system to actually run a very, very large single MPI job, or do you expect it more often to be running several or dozens of smaller jobs simultaneously?
In practically, now I don't think so much full MPI program, so 80,000 processors are simultaneously used by one job. So it is of course available, and it is a final target of the final usage of that K computer. But so in most of the time, so several or dozens of programs are used simultaneously in the K computer system. K computer has partitioning facility, so the K computer system can be divided